We have the initial, and then we rotate over to the terminal, right? We remember that from yesterday. That wasn't too bad yesterday. Now, this is a lead up to the filling in the rest of our unit circle. So kind of stick with me. You'll see where it fits in big picture. If they tell us we have this point here, -4, 3, and we wanted to find, our goal was to find the radius of that circle, we could do that, right? -4, 3 means we moved to the left, -4, and we moved up 3. So we could use our Pythagorean theorem to find the radius, couldn't we? Right? We could use Pythagorean theorem to find the radius, if I say so. Yeah. So that would mean that, let's see, we have a side, and we're looking for the hypotenuse. So r squared equals 3 squared plus -4 squared. Does it come out clean? Okay, perfect. So we would find that r is equal to 5. All right, so again, we're going to work towards filling in the rest of our unit circle, so you'll see where this fits in. But if we found that the radius of this circle, now, like I said, this is at a point on our graph, -4, 3. We are working on the XY axis, right? We're working in the coordinate plane. And this is something that you should have probably been introduced to at the end of geometry, which I know might be a stretch for a lot of us, end of geometry, and also a little bit in algebra. But we're working in the coordinate plane. We have a circle drawn in the coordinate plane, and we are at the point -4, 3. And we would like to find the radius of this circle. Well, we just found it with 5. Now, where's the rest of it? Be a point on the terminal side of the angle in standard position. Evaluate the 6 trigonometric functions of theta. So what are the 6 trig functions that we've talked about? Give me one of them. Levi, then Ryan. Ryan. Oh, you're skipping. What else? Besides you two. Yeah, Keelan. Yes, Faith. 2 more. Probably the ones where, yep, secant. Last one. Someone we haven't heard from. We have cotangent at the bottom. It does start with a C. Close. Cosecant. Which is represented like this, cosecant. Now, remember, our SOHCAHTOA. SOHCAHTOA. If we have sine, we'll say sine of theta. That would be our opposite, which from, oops. I know it says theta here. That's a little bit deceiving. We are going from the perspective of this inside angle here. Okay? If we were writing the sine, so the opposite over hypotenuse, the opposite would be what? Good. And the hypotenuse is 5. So look, we just did our first trig ratio with this circle. Cosine of theta would be -4 over 5. Good. The tangent would be, let's see, yep, -3 over 4. Cosecant, what are we flipping? Yeah, sine goes with cosecant. S goes with C. So we have 5 over 3. Secant, we are flipping cosine. And cotangent, we are flipping tangent. Yep. So those would be writing or evaluating the 6 trig functions at theta. Now, with number 1 and number 2, you got to do the same type of thing. It gives you 2 points in the coordinate plane. For number 1, it gives you a point. Number 2 gives you a point. And you need to sketch in your little triangle with the right angle, find what the radius would be, and then give the 6 trig functions. Ready, set, go. And it seems weird that we have negatives involved, right? But if we look at being on the coordinate plane, it makes sense. We're going back 4. We're at -4 with this bottom leg.
If there's a root in the denominator, do you want us to?
Yes. Yep. Get the root out of the denominator. I'll give you, those take a little bit of time, so I'll give you a minute or two to work on those. Yeah, this is just the example. Sorry, I lied when I said I was doing homework for you. What? I showed you how to. You did not. When I do your homework for you, I put up in the corner me doing your homework for you, and then put the question. Also, it's not the same number. Just leave it as root 13. Yep, leave it as root 13. Don't use the decimal.
Are we going to save like perspective from this screen?
Yes. Yep. Yep. How you guys doing? Remember, on a quest, then we don't like square roots in the denominator. So I think for your very first one, the sign of that very first one, it'll be something over root 13. What over root 13? So it's 3 over root 13. We need to rationalize the denominator.
How do you do that?
Multiply by root 13 over root 13. You multiply by that square root to rationalize the denominator. This will be helpful because when you want to find the cosecant, you just want to flip the beginning. Then we're okay. Right? We can have the square root in the numerator. But this is probably what you would need all there for the sign in the first one. Yes. Yep. Well, if only if there's a square root at the bottom. Cosine.
There's only like 3 questions, and they're all with 1 point, and it's worth 500. There's like 5 questions. That was a waste of time. I did it too.
Only if there's a square root at the bottom.
Yeah, there are a couple of quick questions. Like 1 or 2. They're only worth like 2 points.
That's all her note sheet is.
Yeah. I got like a C.
Rationalize the denominator.
I got not even capped. Yeah.
So like you can see like bottom right side, mid right side of the board. The sign for this. Sign is root 13. So we rationalize that by multiplying by root 13 over root 13. And then we multiply cross with 3 root 13 on top, and then root 13 and root 13 is just 13. Yeah. It gets rid of the I didn't add the upload the 9.3. Hey, I was slacking on the Canvas page for the virtual students. Let me upload it. And then we'll keep moving forward.
You gonna win today? I'm coming. You are? All to cheer anytime.
Trey, why are you doing this?
Because I've got nothing better to do on Wednesday.
No, you want to support your
Oh, I really want to
classmates.
support our Lady Orioles who are really fun to watch.
All right, there you go, Keelan. Go ahead, refresh. Yep. Good to know none of the virtual students start their homework before 11:30. Come on. All right. Whoops. Let's keep moving.
Sleep's important.
Now, when we talk about specifically with the unit circle, and you've probably seen this before, this is technically the equation for a circle. This is how, if you put this in your graphing calculator and your y equals, then you should be able to have it graph a circle if you type it in correctly. But this is how we get a circle on the coordinate plane. Now, when we talk about the unit circle, a unit is, I'm watching, Josue, I'm waiting.
What?
I'm up. I'm going to be up 2-1 here soon if you're not careful.
I'm always careful.
Yeah, you should be.
This week.
I'm waiting.
Just wait.
Uh-huh.
Just wait.
I'm waiting. I'm here.
Caleb, I might need your help.
Anyway, when we're talking about what is a unit? Like how many things is a unit? Is just one, right? So the unit circle, it would make sense that we're talking about a circle where the entire radius is just one, like it says in the text here. Now, again, we're going to fill in the rest of our unit circles. Something you need to write on your page and take note of. Like it says, the sine and cosine of theta, on the unit circle, instead of having x comma y, we have cosine comma sine. And you can add theta in there if you want to, but I would write at the top of that unit circle page, x comma y, and right below it, write cosine comma sine. So on the unit circle, instead of talking about coordinates, instead of talking about coordinates with x, y, we have cosine and sine. To talk about how far left and up we're going, how far right and up, or whatever it might be. We will finish filling that in once we get to the end of the slides. So, let's see, this would be the next part of your homework. Here's an example for number 5, 6, and 7. Use the unit circle to evaluate the 6 trig functions of theta equals 270. So if we think about our unit circle, 270 would be right here. So we will be able to do this very quickly later on, but if we want to find the sine, cosine, tangent, where theta is equal to 270 degrees, what's a very quick way to do that? Put in your calculator. We'll get to that in a second. But we can just put these right in our calculator. What is the sine of 270? Did you get a decimal, Faith? Because you might be in radian mode if you did. Cosine of 270. Now, when you put tangent of 270 in your calculator, what does it say? You get an error. Now, like I wrote on the board, I don't know if this is something you've come across yet. You might not have. But tangent, we get tangent from, and it is the same thing as sine divided by cosine. Have you guys seen that before? Or is that new information to you? Well, yeah. But in algebra, you wouldn't have seen it probably in geometry, but in algebra 2A, did that come up at all? Okay. So something to keep in mind is that we get our tangent ratio from the sine over the cosine, or sine divided by cosine. So in this case, if the sine is -1 and cosine is 0, can we divide by 0? No. So that's why the tangent of 270 is undefined.
Yeah, mine said like quit.
Yeah, it's undefined. Good. Now, let's keep going. Cosecant at 270. Well, cosecant we know is just sine flipped over. So it would still be -1, right? Because our sine is -1. So if we flip -1, it's still -1. Yep, cosecant of 270 would just be -1. Is that making sense, or do I need to talk through that again? Okay. So we know that cosecant is our sine flipped over, right? So sine -1 can be written as -1 over 1. If we flip it over, it's still -1 over 1. Yep. Very close. So cosine would be this, right? We can write our cosine as 0 over 1. If we flip it, it would be undefined. Mm-hmm. Now, last one, tangent. Oh, just wait, this is going to blow your mind. Tangent, remember, tangent is sine over cosine. Sine over cosine. Now, if we flip it, oh, sorry, our cotan at the bottom would be 0. What question? I know that's a lot, but I don't think that's overly difficult. Now, if we look at our unit circle, let's fill in one of those cosine sine coordinates. What did we just find? That was 270. So go into your unit circle, look at where 270 is all the way down, and we know that the coordinate points of 270 would be with our cosine and sine. So it would be 0, -1 would be that coordinate. We will fill in the rest, but we just found that one, so let's start right there. Now you're going to use the same process for number 5, 6, and 7. I'll give you some time. You're not going to get through all of them in the time that I'm giving you, but I'll let you get started and try to work through number 5. Actually, 5 and 6 I want you to get through. You kind of already did number 7. That's a good question. We don't use them a whole lot. I think there is a way, to, if you hit like math, I think you can scroll through and find one. But don't quote me on that for sure.
Wait, so is it sine over cosine for tangent or cosine over sine?
Sine over cosine. That probably would be something that also would be helpful on your unit circle page if you're writing notes somewhere. That might come up a little bit more in the future as well.
Let's see. Can't
Cosine.
so if it's 0,
It is. Yes. If you can, try to get through number 6. And we can't divide by 0. I'm pretty sure that would be undefined.
Zeros on the zeros on the numerator, it's still counting.
Right, then it's 0.
Yeah.
Flip it. Yeah, so like 0 over 1, and then flip it to get cosine. So cosine would be 1 over 0, and that is undefined. You can't divide by 0. It'd be the same idea here. This sum, this is 0 over 1. And you flip it, and it's 0. So 0. How do you do it?
Hey, where's the pi button?
So that would be carried. That would be this one.
Okay.
If we flip it, it's still negative 1.
Okay.
Why do you think the last one?
You guys okay? Good? Okay.
It's the same as 278. It's the same as what we was doing.
We will keep moving. You guys are doing a good job.
Thank you.
How many of you got through, and it's okay if you didn't, got through number 5? Finished number 5? Most of you did? Okay. Now we found 180 degrees in number 5. That's one of our points on the unit circle, isn't it? Now if we are filling in some of those coordinates, what would our xy coordinates be then? Or our cosine sine coordinate? Negative 1, 0. Go ahead, fill that in on your unit circle.
Wait, what?
So we found all the trig ratios in number 5 for 180 degrees. 180 is on our unit circle. So that cosine sine coordinate would be negative 1, 0, which makes sense, right? I mean, if we're talking about a regular xy coordinate, that would be over, well, for you guys, at negative 1, and we are not going up at all. So if we're thinking xy coordinates, if we already know that 270 is at 0, negative 1, And if we also know that 180 is at negative 1, 0, then where would 90 degrees be at? Would be at 0, 1. Where would 0 or 360 degrees be at?
1, 1.
Not 1, 1.
0, 0.
No, 0, 0 is the origin. At 1, 0. Yep. That would be our 0 and 360 degree spot. Well, we wrote yesterday that we have 0, 360 is at that same spot. That's our initial position. If we were to write that, and that's in terms of degrees. If we write it in terms of our cosine, sine coordinates, it would be at 1, 0.
So let me guess, 90 is 0, 1.
Yes, 90 is at 0, 1. You can fill that in as well. So we should have 4 spots filled in our unit circle so far. The rest we will fill in after I teach you one more thing so you can do the rest of your homework. Okay, the next idea, we're taking not a break from unit circle, but a break from finding those points. We'll come back to it and finish it in a second. But the rest of your homework, numbers 8 through 13, all talk about this idea of a reference angle. And let me read you what our book defines a reference angle as. For theta, a reference angle is the acute angle formed by the terminal side of theta and the x-axis. That's what our book says. What that means to regular people is here. We have our coordinate plane. Here would be our initial position. We rotate around to our terminal position. Now, the reference point is talking about the distance from our x-axis to our terminal position. Whichever x-axis is closer. So, in this second case, we rotate all the way around, and we still have this part of the x-axis, which is closer, the negative side. In this fourth case, when we rotate around, the positive side of the x-axis is closer, so the reference angle would be whatever that distance is. Now let me show you an example. It sounds a little bit complicated. It's not anything too crazy. It says find the reference angle for 5 pi over 3. Now if we think about our unit circle, halfway around is just pi. So we at least go halfway, and then we have to go another little bit here. Oops. There we go. Now, 5 pi over 3 should sound a little bit familiar if you look at your unit circle from yesterday. 300 degrees? Yes. Where's my unit circle? There it is. Am I not at 300 degrees? Oh, whoopsies. My fault. Yes. Now, if we are talking about the reference angle, we're talking about this angle right here. So how many more, not how many more pi's, how much further do we have to go? So we know it's at 300 degrees if we're thinking in degree mode, which might be nicer to think about. So we need another 60 degrees to get to our x-axis. Now, if they start out the question in radians, we need to answer the question in radians. So how many more pi's do we have to go? Pi over 3? I would agree. Did I lose everybody going from radians to degrees, or is that not too bad? We also should keep in mind when we're at 5 pi over 3, remember that getting to this point, getting to this x-axis, this would be at 6 pi over 3. or 2 pi, we call it. It's all the same thing. So the fractions make it a little bit messy. When they give it in degree mode, it's no big deal.
Maybe I can have a negative. If it's
If it's
and then 190.
like here,
Yeah.
yes.
Is that gonna be
Now, let me see if they want you to write that. No, you won't write it as a negative. You'll still write it as a positive answer. So, like if this was back, if you went back 50 degrees, you would write it as 50 degrees is the reference angle, which does seem backwards. That's a really good question. And I should ask Shoop why that is. Why would you not write that as negative? Now, this one will be a little bit easier. We are starting here. We're going backwards 130. So here's 90. 130 would be about, about right here. Now again, our reference angle is talking about the distance between the closest x-axis, like the positive side over here, or the negative side over here. So this would be our reference angle. We know this is at 180. We know this is at negative 130. So what would our reference angle be? Good, 50 degrees. Now, we don't stress about reference angles, okay? We don't use them a whole heck of a lot. But it is something that we need to put in front of you. So that should get you through. Why don't you take 2 minutes and work on 8, 9, 10, 11, 12, 13. That'll get you through the homework. I'll give you a couple minutes to do that, and then I want to finish filling out our unit circle. Just a second. Let me freeze this. Yeah. You have a question? Okay. Let me quick check with Ryan. Maddie asked for
I don't feel you can really make that up. There's no way you know how to do it.
You're saying that because you made it up?
He actually did.
So whichever part of it is.
He barely got it. Look. Back at the heel.
You guys are doing good.
Yeah,
I got to think about how to.
Alright, I'll go actually start to that.
Well, you're going to have to fast forward a lot. There's a lot of dead space. Or we can talk about it next hour, too. I'm sure Grace would turn around and catch you up. She's probably got it down. For sure, definitely. Also, there's a lot of geometry in this, so Bryn could probably help you out a little bit. Yeah, maybe. You got it? You didn't find that? For that one or the next one? Now the next one. Same idea. We got to find where that's at in the circle. Remember, like 8 pi over 4 would be 1 pi over 1 times pi over 4. So like 8 pi over 4. Now it'd be 12 pi over 4. You know, the 15, so we're going to go 3 more pi. So 3 fractions of pi. The other thing you could do, which if you hate thinking about things like this, convert it to degrees first. Find it. Find the answer in degrees. And then do that. You know what I mean? Well, you know how to put this in terms of degrees, right? That's what we worked on yesterday. You have to multiply it by 180 over 5. So you could write it in terms of degrees. How come where's 15 times 180? Then you could find that point if you wanted to.
I went into it. Yeah, that's pretty cool. Although I think I would have no, it's negative 1. I'll always be able to that's it? Oh. I thought it was a lot more than that. It was like 130. Let's go to 135. So
I can
number
open that
9
for you.
is 130. I go to 130.
To make sure I'm not forgetting something, because I have not finished the key yet. It's not quite done yet. It's almost done.
You have the last two.
No, I do not. Number 12 is pi over 4. I need to look at that another second.
How is 12
I will. It is pi over 4. I'll look at it for a second. What? We'll look at it. Let's finish filling in our unit circle so I can stop recording. I haven't gotten that one yet. How do I make another slide? I want one more. So let's finish filling in our unit circle because I think we can do this pretty well. I'm just going to talk about the first quadrant first, okay? We know so far, when we're talking about our coordinate points, we know that our points have to go cosine. Oh. We know our points have to go cosine sine, right? We know right here we are at 1, 0, which makes sense with, I mean, even if we're not talking about cosine, sine, tangent, all that stuff, it makes sense that it's at 1, 0, because that's what we're used to, over 1, up 0. Now, how many degrees is our first line? It's up 30 degrees. Now, if we go back to these special right triangles that we talked about earlier, what did we talk about the radius being for a unit circle? What is the radius? It's just 1 unit. So here, we're looking at our special rights. Actually, I want Actually, did you just have a moment? If we look at our special right triangle from the perspective of the 30-degree angle, if we know that we are going cosine, comma, sine, and we know our TOA from the perspective of the 30-degree angle, right, on a unit circle, what is our cosine?
0.86603.
Not quite. Well, it would be 1/2, right? Our opposite over, or our adjacent, wait a second, did I draw it wrong? Dang it! Our cosine, adjacent over hypotenuse. Very good. Well, you said 1/2. Not very good, sorry.
Wait,
That would be the sine.
It goes 0.5 in the next one.
Well, just wait a second. Just wait a second. Who did? Cheater.
I did too.
We'll get to that in a second. Hey, we're trying to bring it all together here. Give me, and I know I messed up for a second, but if we are looking at our cosine, we have adjacent over hypotenuse. So our cosine from 30, our first point, our x value, root 3 over 2. Now what would our sine be? Which is the 0.8, blah, blah, blah. What is our sine? 1/2. Now if we move up to go from the perspective of our 45-degree angle. Again, we know that the radius is just 1. So if we're looking from the perspective of our 45-degree angle, what is our cosine? Root 2 over 2. And what is the sine? That's in simplified form. Root 2 over 2, that's getting the square root out of the denominator.
Where's this root 2 coming from?
So we can have a square root on the bottom. So from here, if we're looking at our cosine, it would be 1 over root 2. We don't like square roots on the bottom. So we multiply.
Yeah.
Root 2 over 2. It is the same thing. It would be root 2 over 2. And that would be our 45. What about now with our 60? Now we're going from, sorry, it's really small. I should have written it bigger on the board. From our 60-degree angle, from this perspective. If we are looking at our cosine, it would be what over what? It would be 1/2. It would be our cosine. What about our sine? Root 3 over 2. Nice job. And sorry I don't have an awesome amount of room here. Now we already know what this is, right? Because it's just 0, 1. Now if we're moving this way, what do you think our points would be like going this way? Yes, Ryan? Very good. We would have negative 1/2, right? Because we're going over in the negative direction. And we're going up root 3 over 2. Everything we do from here on out, like filling in the rest of our unit circle, will be some combination of 1/2 and root 3 over 2, also root 2 over 2, and root 2 over 2. If we go from our 135-degree angle, right? That's just like our 45 here, except now we are going over negative root 2 over 2. And we are going up root 2 over 2. If we go from our 150-degree angle, not yet. We'll get to a negative eventually. If we go to our 150-degree angle, how far are we going over? Negative what? Negative root 3 over 2. How far are we going up? 1/2. You guys are catching on pretty well. Good job. Exactly. Now when we go here, we know it's negative 1, 0. And we can continue to fill those in. How far are we going over once again? How far are we going over? Just like we did last time. Negative root 3 over 2. And we're going down this time. Negative 1/2. Now with our 225-degree, we are going over or left negative root 2 over 2. We're going down negative root 2 over 2. at our 240 degree mark. We're going over just a little bit, just a little 1/2. And we're going way down negative root 3 over 2. Now where are we at 270? We're going over just a little positive 1/2, and we're going way down negative root 3 over 2. We're going over a decent amount and down negative root 2 over 2. Now this time we're going way over root 3 over 2 and going just a little bit down. Just a little negative 1/2.